So hello guys, today we are going to solve a late code question that goes by the name binary tree level order traversal. Question number is 102, and so we'll first start by reading the problem statement. What does the problem statement says? So it is given the root of the binary tree, return the level order traversal of its node values, that is from left to right, level by level. Okay, so it is just a traversal technique. It is just a traversal technique. Basically, there are four traversal techniques while traversing a tree. If you are trying to traverse a tree, there are four traversal techniques. Okay, one of them is pre-order traversal, pre-order, post-order, in order, and then level order. Okay, level order traversal. So, what do you mean by level order traversal? Basically, what do you mean by levels? What are levels? Suppose it is here comes a binary tree 1, 2, 3, 4, and 5. If this is a binary tree, then the nodes that are at the same height are considered as a level. The level starts at level 1, that is of the root node. Suppose this is the root node. So the root node is at level 1, and while going down, one step counts as one level. One steps count as one level. So all of these are at level 2, and all of these that are basically one level down than this, it is on a level 3. Okay, so what you have to return, basically you have to return the level order traversal from left to right. So you have to return it in the order, basically first 1, then 2, first 1, then 2 to 3, 1, then 2, then 3, and then basically traversing the third level, then 4, and then 5. So this is what you have to return. This is what you have to return. Okay. If I see what are the number of nodes at each level, so at the first level there is only one node. At the second level there are two nodes, and at the third level there are two nodes that are connected to the rightmost subtree, basically rightmost node, that are the children of the right node. Okay. So if you are given a tree like this, what would be the level order traversal for this? Basically 4, 5, 6, and 7. Okay, if you are given a tree like this, what is the level order traversal gonna look like? So the level order traversal is gonna look like first 1, then 2, then 3, basically traversing like this: level 1, level 2, and then level 3, left to right. 1, 2, 3, then 6, then 7, then 4, then 5. So this is what you have to return. Okay, this is what you have to return. So how will I do this? How will I do this? If I can observe a pattern, if I can observe a pattern that for every node, basically the left node is traversed first, the leftmost nodes are traversed first, and then the right nodes are traversed first after the left node. Okay, so the left node is traversed first, and then the right node. Okay, so this pattern will follow. This pattern will follow for all the subsequent nodes. This pattern will follow for all the subsequent nodes. Basically, for 1, first 2 will be pushed, then 3. Okay, then 3 will be printed because we are going like this: first 1, then 2, then 3, then 6, then 7, then 4, then 5. Okay, so this would be the order. If I come to this node, 6 will be pushed first, then 7, 6 first, then 7, and in this 4 will be pushed first, then 5. Also, the second node should be, the children of the second node should be served first. Should be served first. As you can see, okay. So if this is my tree, this is my tree, 3, and then 4, 5. Okay. So what I have to print? 1, then 2, 3, then 4, 5. Okay. So I will have to do? I'll have to, if what I'll have to do, I'll have to give this node the priority before this third node, the left node would be given priority. The left node would enter the list first. Basically, we are using a list. Okay, not list. If we just come to the data structure, what we will gonna be using is the queue. Why queue? Why we are using the queue? Because I want that the nodes that are coming first, like the left node is coming first, right? Left node, I want that the left node should come first and then the right node, and the same should follow for all the subsequent nodes. Basically, for one also, the second node should come first and then the third node, and for second also, the fourth node should come first, then the fifth node. Okay, and this has no children, so this would simply return for both the cases. Okay, so I will be using the queue data structure for fulfilling the conditions. Okay, suppose if this is my tree 1 2 3 4 and 5. Okay, 4 and 5. What I want is, if this is my queue and this is the front of the queue, this is the front of the queue, this is the front of the queue. What I want is, if I start from the root node, if I start traversing from the root node, I want the I will push the root node first, because this would be coming at the first for sure. So this would be covering the level 1. Okay. And then what I want that I should cover the left node first. So I'll go to 2. I'll add it to the queue because I want it to be investigated. I want that the the children of node 2 should be pushed first because what if I push the children of 3 first, basically if 6 and 7 are there, if I try to push these first, then what will be my order be like? It will be like 1 2 3, then 6, then 7, and then basically 4 and 5, so this is not right now. We have to push we have to push we have to push such that my leftmost nodes are coming first and then my right node. So if I push the second node's children first and then the third node, then I can make them to serve first. Make them to be served first. Make them to be served first. Okay. So coming back to the question, if my second node is served first, then the third node would be added here. Okay, so these are pushed. Okay, what if I come to the second node? What will be my priority order? My priority order shall be fourth node should be pushed first and then the fifth node. So I'll add it to my queue, 4 and 5. And if there are nodes present here, I want that 6 should be pushed first and then 7. Okay, 6 push first and then 7. So if I can see, I have in the queue the particular order that we want to traverse: 1 2 3 4 5 6 and then 7. Basically 1 2 3 4 5 6 7. Okay, so this is the order that we are following. Okay, we will not be adding all the elements to the queue. I'm just trying to explain how it can be resulting in the solution, how the queue is resulting in a solution. Okay, how I would run this, I'll simply explain by taking a test case. Okay, 3 9 20 15 17. If I take this test case, 3 9 20 15 and then 7. Okay, if this is my test case, if this is my tree that is present, and this is my queue, this is my queue this is my queue, and I am currently at my first node. Basically, if I am at this node. Okay, So what I'll try is I'll first just put it in my queue. I'll just first put it in my queue because it is forming the level one. It is forming the level one. Okay, I'll put it in my queue. Okay, so as we are finished with the level one, I would simply get the size. I would simply get the size of the queue. I would simply get the size of the queue till what we have to go till what we have to go till what we have to go to get all the elements access. Because how I want to travel, i want I want to come to third node first, then to ninth, then to 20. Okay, so if I add them in this order, like 3 then 9 then 20. Okay, so I can get access to them in this particular order. Okay, I can get access to them in this particular order. Okay, so for now, okay, for now, if 3 is added to my queue, 3 is added to my queue, I can simply get access to this queue by just popping it, by just popping this element and getting access to it, popping this element and getting access to it. Okay, I'll store it in a variable temp, and I'll make sure to add the left and the right child of the node, left and right child of the node, left and right child of the node to the queue, left and right child of the node to the queue. Okay, so left and right child of the node to the queue. Okay, uh, left and right child of the node to the queue. Okay, why I'm doing this? Basically, if I want to add, see, I want access in this order, right? I want access in this order. I want to access this node first, then this, and then this. So I will add them. I will add them in my queue such that I'll get the third element first, then 9, and then 20, and I can pop them out. I can pop them out, and I can pop them out to get access to each of the element, access to each of the element or to node. Okay, and I can add them, I can add its children again, I can add this children again to the queue, so that these are given access first, and then I can add these children, so that these would get access after these nodes. So first this would come on the fourth mark, and this would come on the fifth mark. Okay, so by adding them in the queue, I am simply manipulating, I am simply trying to manipulating the order in which, the nodes would be accessed. Okay. So what I'll do for each node is, for each node, for the root node, I'll push it first in the queue. Okay. And for each element, for each node, I will push its left and right child, so that I can get access to the second node first, and then the third node, Okay, so I would get access to this node, so I can extract its children. I can extract x and y first, and then z and p. Okay, if these are my nodes, so I can get access to this first and then this. Okay, if I push 3 first, if I try to push 3 first, and instead of 2, I try to push 3 instead of 2 first, so I would get access to 3 first. So these children would be pushed in the queue first. Okay, so Z would come, Z and P would come before X and Y. Okay, so this would result in a wrong order. What I'll do is I will push. For each node, I'll push the left node and then the right node. Each node, I'll push the left child node and the right child node. And I'll do this for all the nodes. We'll see that we will get to an answer. Okay. Also, you have to keep a track while while trying to switch between levels. You have to keep a track that what are the current number of elements that are present in the queue as of now, because if you don't know that track, you don't basically, if you don't know there are two elements in this level, you will not have a you will not have a stopping point. Okay, as you want the level to be segregated. So as I will traverse this and I'll add these children to the queue, I'll simply push them to my queue. Okay. Basically, if this is my tree, okay, and I'm at my first level. Before pushing it, my queue is as of now this, like this. Okay, before pushing the left child and the right child, before pushing the left child and the right child to the queue, I'll get an empty queue. Okay, and I will add this one. I'll see my current queue length, it is 1. Okay, I'll add it to 1, that is one element is present in the queue. I'll simply add this one element to my vector and add this to my 1D vector, and I will add this 1D vector to my 2D vector. Okay. So what we will get is basically we will segregate all the levels, because if I know that there are two nodes in this level initially, so I shall traverse only two nodes and push them into the current level, current level, into the current level. Then only then only I would get access, to the, then only I would be able to segregate the levels. Segregate the levels. Exactly. So if we come to the test case, if I try run it, 3, 9, 20, 15, 17. Okay. So this is my test case, 3, 9, 20, 15, and then 7. This is my empty queue as of now. Okay, I'll come to the first element, that is, suppose basically my pointer is T. Okay, I'm coming to the first element, I'm adding it to the queue. I'm adding the first node to the queue because I want this node to be served first. Okay, what I'll do is I'll get its size. So my size of the queue is 1. How I am getting the size? I'm just checking the size of this queue, and whatever is the size of this queue, I'll just simply take it. Now I'll traverse from 0 to 1. I'll traverse from 0 to 1. That is basically one node. I'll simply pop it up. I'll simply pop it. Okay. I'll simply pop it and get access to it, so that I could traverse its children. Traverse its children. Okay. So I will be accessing only one node in this level. And I will be pushing the left child first, and then the right child, because for the subsequent levels also I want access to the ninth node first, and then to the 20th node. Okay, so 9 would be pushed first and then 20th, because it is a FIFO queue. The one enters first is served first. Okay, so my 9 is at the front. As of now, my 2D vector would contain only this. Basically, there is only one level as of now. There is only one level as of now. Okay, I'll again take the size. My size is 2. That is at my second level, two nodes are present. Two nodes are present. Okay, I'll try to get access to the first element. Okay, so if I get access to the ninth element, this was my tree. What was my tree? 3, 9, 20, 15, 17. Okay, 3, 9, 20, 15, 7. So if basically my queue is like this, 9 and 20, my n is 2. Okay, if I get access to this element, I'll simply pop it. My queue would only contain 20. I'll simply pop it. I'll push its children to the queue. So to get priority access, but there are no children, but it has no children, so nothing will be pushed. Okay. But now my output queue, my output value would be a vector that would contain a single line that is yet to be added to the 2D vector, but my 1D vector contains a 9. There exists one element that needs to be pushed before this 1D vector will be merged with the 2D vector. Okay, I'll try to get access to the 20th node. Then because it is following the left to right priority order, so I'll try to follow it. Okay, I'll get access to this 20th node. My queue becomes empty. My pointer is here. I am getting access to this. I'll push 15 and 7, that is the two nodes in the order left and right, because I want to get access to 15 and then 7. Okay, I'll push 15. And 7. Okay, this is my current queue. Okay, and my 1D vector would now look like 9 and 20. That are the nodes that were at these levels. Basically, 9 and 20 are at these levels. So it forms my level 2. Now this 1D vector can be added to my 2D vector. So my 2D vector would become, 3, 9, 20. This is what my 2D vector looks like as of now. Okay. If I again make the tree, okay, this is somewhat my queue looks like. 15 and 7. What I'll try to get access to, 15. I'll pop it out. My queue contains 7. Okay, as it has no child elements, nothing will be pushed. Okay, but it is added to my 1D vector, so 15 is added to my 1D vector. It is still yet to be added to the 2D vector. I'll come back. I'll try to get access to the element at the front. I see its children, there are no children, so I'll push nothing. My queue becomes empty, and this is the condition where I have to stop. When my queue becomes empty, this is the condition I have to stop. Okay, so as there are no children, I'll simply push it. So my 1D vector would contain 15 and 7. Okay, as the level had only two nodes, so this is ready to be merged with the 2D vector. Okay, so my 2D vector would look something like 9, 20 and then 15, 7. 15, 7. Okay, this is what my 2D vectors look like. Okay, I told you about the condition that we have to stop at. This is the stopping point. But bhaiya, when we are starting, suppose this case 23, 4. Okay, if I consider running and I take this size, then my queue will be empty, right? It will never be executed, right? Because my queue is initially empty, so it will never be able to start. So initially I will be pushing the root element to get it started, because I know that the root level 1 would only consist of one node always, and this node shall be pushed to the queue, and then the priority order should be maintained. First the left and then the right. Okay, if I try to write the code for this, what I want first is I want the 2D vector that would be supporting my answer, that would be containing my answer. Okay, I want a queue that would be consisting of the tree nodes, and then I'm denoting it by q. Okay, so I'll be pushing the root node first. I'll pushing the root node first because I know that it will be forming. It will be forming the first level. Okay. So while queue is not empty, as this is my condition, base condition, that would be stopping my loop. That would be stopping my loop. Okay. What I want is I want to get the access to the first element in the queue. Okay. Then I'll pop that element. I'll pop that element. Okay. And I'll get the current size of the queue. I'll move to the current size, and on my way, what I'll do is basically here we have to do this. Yes. Okay, and I will be declaring a vector that will be my 1D vector that will be storing my all the nodes at the current level. Okay, I'll get access to the node at my front of the queue, and I'll be popping that element. I will be popping that element out so that I could push its children. I will be pushing its children, but I will be pushing them only if they exist. Okay, so if temp of left exists, then I'll push temp of left. If my temp of right exists, then I will be pushing temp of right. Okay, and I will be adding the 1D vector to my 2D vector. Also, I will be adding all the values in the 1D vector that I traversed. Okay, I will be returning my vector 2D vector at last. I'll run it. Okay, let's try to see what happens. Ah, why it is giving this error? Why it is giving this error? Access null pointer. Okay, basically it is considering the case where your root is equal to null. Root is equal to null. So we haven't included this case. We have to include this at the start. If the root is null, then I have to return an empty array, empty vector basically. I'll try to run it. Okay, it ran. I'll try to submit. Okay, it ran. Okay, so if I try to explain you the code line by line, this is the base case. If my root doesn't exist, if my root is null, okay, if my root is null, then there is no pre-order traversal existence. So I'll just simply return. This is my 2D vector that I'll return. Okay, this is the queue of nodes. This is the queue of nodes for deciding the priority, in which node should be accessed. Okay, I'll try to pushing the I'll push the root node at start because I know that it is the only node at level 1. So I'm basically pushing it as I know that it is the only node at the level 1. Trying to get the size. I'm trying to get the current size, or this would be identifying how many elements are there, how many elements are there in the current level. Okay, so that I can easily segregate them. Basically, if 1, 2, and then 1, 2, 3, these are at different levels. Suppose this is first level, then this is the second level, this is the third level. Okay, this is the third level. So I want to know that it contains only one element. Now this contains only two elements, and this contains three elements. Okay, I'm just clarifying it down. I'm just trying to get the size of the queue that will determine how many elements I have to segregate. Okay, and then I'll be declaring a 1D vector that will store 1D vector that will store the current level elements. Okay, I'll traverse for all the elements at the current level. Okay, at the current level, get, getting access. Then in this line, what I'm trying to do is I'm trying to get access to the first node. Access to the first node, that is the highest priority node. If I see that the second level, if I see at the 9 and 20, what is having the highest priority? Highest priority means what should be accessed first? Ninth node should be accessed first, right? Because I have to get the traversal from left to right. Okay, I'll push the left node first. I'll push the left node first, and I'll push the left node first. Okay, and for this, I'll push the value in the node. Okay, if there exists any child, any left child. Okay, if there exists any left child, I'll simply push it because I want that the left child should get the priority first, and then I'll get the left child, and then I will then push the right child, and then push the right child. Okay, I'll then push the right child. Okay, because I want the right child to have a lower priority than the left child, so it will be pushed second. Okay, answer pushback, and this line what it will do is it will be merging my 1D vector with my 2D vector. Okay, so this was all about the code. I am using a queue, using a queue, using a queue to get access by priority. And what is my priority order? My priority order is that left nodes should be accessed first. Left nodes should be accessed first. Okay, if I want that the right node should be accessed first, so I can push this line to the top. Okay, so in this, my right node would get the priority, and 20 in this case would be pushed first. Okay, so this was all about the code. This was all about the code of the left order traversal, of the level order traversal of a binary tree. If you have any doubts regarding this solution, you can just comment it down in the comment section. If you do like the solution, do like, share, and subscribe. Thank you. Have a nice day. Bye bye.